So to finish up section 2.2, let's do an application problem. This is example 2 on the handout. It says the total number of passengers riding a certain city bus during the morning shift is 1,000. If the child's fare is 50 cents and the adult fare is $1.50, and the total revenue from the fares in the morning shift is $1,300, how many children and how many adults rode the bus during the morning shift? What you should notice that this example is one that we wrote the equations on, just the other lecture or the other section. So we wrote these equations already in section 2.1. So it's kind of nice to come back and revisit those problems and finally finish them. So again, just to remind you what we did, we let X be the number of children that rode in the morning, and we let Y be the number of adults that rode the morning shift. And then we wrote 2 equations. We know all together we've got 1,000 people riding. So that's X plus Y is equal to 1,000. We know that each child was 50 cents. So if I take 50 cents times all the children's tickets, I'll get how much revenue they brought in. And if I do the same thing for the adults, multiplying by $1.50 times the number of adults that rode, we'll get how much money they brought in on adult tickets. And together we know we brought in $1,300. So those are our equations. Again, we wrote this the other day, so it should seem a little familiar to you. But now we're going to go solve it using Gauss-Jordan. So the first thing we're going to do is take it to our matrix. So we're going to have a 1, and a 1,000. We also have 0.5, 1.5, and 1,300. So in general, I try not to use decimals, but because the problem initially starts with decimals, I'm going to go ahead and keep the decimals in as I work the problem. Now it's time to row reduce it. Well, we already have a head start because this is already a 1. So now we need a 0 right here. So to get the 0, we'll do row 2 minus 0.5 times row 1. So row 2 minus half of row 1. So that's, again, I'm going to copy over row 1 because we're not manipulating it this go round. Okay, so 0.5 minus 0.5 gives me a 0. 1.5 minus 0.5 is 1. And now I have 1,300 minus 0.5 times 1,000. Well, that's half 1,000, which is 500, from 1,300 is 800. That was enough. So my first column's good to go. That was quick and easy, especially because we already had that 1 there. Now we need to come in and make this guy into our 0, and we can just subtract the 2 rows to get that. So we'll just do row 2 minus row 1. So we'll do 1 minus 0, which is 1. 1 minus 1, which is 0. 1,000 minus 800, which is 200. And the bottom row is good to go. That was really quick compared to the one with 3 equations and 3 unknowns. And we're done. We're row reduced. We know we've got our diagonal of 1s, 0s every place else. Here's our solution. So the first one is our X. We know that X is the number of children. So we know that there were 200 children that rode the bus during the morning shift. And we know that there were 800 adults that rode the bus during the morning shift. And that answers the question, how many children and how many adults rode the bus during the morning shift? And there it is. And that wraps up section 2.2 for us. A little bit of a long section, especially because you're getting used to a brand new method to solve these matrices. In the next section, we're going to take a look at what happens when goofy stuff occurs. No solutions, infinite solutions. What if the number of equations, the number of variables are not the same?